In this video, we're going to discuss something called limiting reagents. When we react substances together, just because we react 100 grams of this and 100 grams of that, does not mean that all of each of those substances will be reacted. There may be something that is left unreacted in the system because one of them got used up. The substance that gets used up first is called the limiting reagent. Once that limiting reagent is used up, the reaction is done. You can't do anything else. Nothing else can be formed. So it's very important to know which substance is a limiting reagent in order to know how much of your product you're going to be able to form. The excess reagent is going to be the substance that is left over at the end of the reaction. Today, all we're worried about is determining what the limiting reagent is. And it's really easy to know that you're dealing with a limiting reagent because they're going to give you two values that you know. They're going to give you two knowns. In this case, they're telling you that you have 5 grams of sodium and 5 grams of chlorine. Now, eventually, we'll say, okay, with this information, tell us how much sodium chloride would form. But today, all we want to be able to do is to figure out which one, sodium or chloride, is our limiting reagent. The first thing you're going to do is to determine the number of moles of each of the substances involved. It doesn't matter if they give it to you in grams, liters, atoms, molecules, moles even. You need to determine the number of moles, if it's not already given, of each substance involved. So that's what we're going to do. We're going to start with our 5 grams of sodium and determine the number of moles of it. So we need molar mass. If we're dealing with grams, the only conversion factor we've got is molar mass, and sodium is 22.99 grams per mole. And we end up with 0.2175 moles of sodium. Now, the nice part about this is we're not going to have to worry about sig figs and scientific notation. We just need to be able to compare the two numbers we end up with in the end. With chlorine, we've got 5 grams of chlorine as well. So we need to figure out how many moles of this we have. So chlorine is 35.45, but since it's Cl2, we need 70.90. Add those together. Grams of chlorine per mole of chlorine. And when we divide this, we get 0.0705 moles of chlorine. So now, then this is the step that people always forget. We have got to realize that this is a balanced equation. And in this situation, we need twice as much sodium as we have chlorine. So to get sodium and chlorine to compare with each other, we need to divide sodium by 2 to see how much we have to compare with 1 mole of chlorine. So dividing that by 2, we get 0.109 moles of sodium. Kind of ran out of room, I'll put it under here. Regardless, at this point, we don't need to divide chlorine by anything because it was an understood one. So we've got 0.0705 moles of chlorine and 0.109 moles of sodium. At this point, you choose the smallest of the two values. Since this is the smallest of the two values, then you're going to say that chlorine, Cl2, is the limiting reagent, and that's going to be your answer. The last thing I want you to do before you go on with another problem or go on to another part of this problem, if it were extended, is to go up and to label each of these substances. I want you to label that chlorine is the limiting reagent, so label it LR. I do not want you to write LR in this answer box down here. I want limiting reagent written out. Sodium then would be the reagent that's left over at the end. Chlorine will be used up. sodium will be left over, and we call that the excess reagent, remember. And believe it or not, excess is abbreviated XS. So you're going to abbreviate the excess reagent with XS. So that's what I want this problem to look like when you're done. Okay, let's look at one more example just to make sure we've got it. And it doesn't matter if we're dealing with grams, liters, whatever, we're going to get to moles for each substance involved. This one says we have 100 grams of acetylene, and we're reacting it with 100 liters of oxygen. And it wants to know which of these is the limiting reagent. So remember, the first thing we're going to do is to find the moles of each one of them. We've got 100 grams of C2H2. The molar mass of C2H2 is 26.04 when you add up 2 carbons and 2 hydrogens. And when you divide that out, we end up with 3.84 moles of C2H2. We're going to do the same thing with our oxygen. We've got 100 liters of oxygen, but now we can't use molar mass here. We've got liters. What's our conversion factor that we can use for volume? Molar volume. Now, technically this problem should have said at STP. But right now, since we haven't studied gas laws yet, we're going to assume that it's at STP. So 22.4 liters to 1 mole. It's our molar volume conversion factor. So the 22.4 liters needs to go on bottom, the 1 mole on top. And when we divide that out, we get that we have 4.464 moles of oxygen. Now, right now, it looks like the smallest number is for acetylene, C2H2, 3.84 versus 4.464. And guys, this is where you're going to make your mistake, because you're going to forget that you must divide by the coefficients. We've got to divide C2H4 by 2. We've got to divide oxygen by 5. And when we do, we get 1.92 moles of C2H2 and 0.893 moles of O2. So now that we've divided these by their coefficients, you can see that oxygen is the smallest of those values. You don't have to underline it, so I'm going to go back and put that in green. And the answer, remember, to the problem is that O2, oxygen, is the limiting reagent. Do not abbreviate that. If you abbreviate it, you won't remember what LR stands for. So O2 is the limiting reagent, and I'm going to come back up here, and just like I said to before, we're going to label oxygen as the limiting reagent, and we're going to label acetylene as the excess reagent, and that will complete the problem.